So when counting to 10, there's quicker ways to do this. We can duplicate a sprite, have another beetle, doesn't really matter if they're beetles, and you'll see it has all the same code. So the cool thing here is that I can quickly change the y factor to 0, and here I can move 10 steps, 90 steps, change the color by 70, should give me different results. Press the space key, and then run the program. So I have 70, 30, 80 and 20, and 10 and 90. So there's 3 different ways to make 10. Now I can keep going, duplicate the beetle again. This is the shortcut. This isn't what I would show students at the beginning. So we haven't done 50-50 yet. So we can do 50, 50, change the y to minus 50, and then run it again. Oops, sorry, I didn't press the spacebar. Okay, run it again. So we have 80 and 20, 30 and 70, 10 and 90, 50 and 50. So then students still have one more they could do. So go here, and this beetle could move 30 and 70. Is that the one we haven't done? So students might say, well, I'm not sure what I've done. So we have them go and check. Maybe it's 60 and 40, 10 and 90, 30 and 70, 80 and 20. And what I encourage my students to do is to record this information outside of the program. So I always like if they have paper beside them or a whiteboard so they can kind of write down what they're working on, what they're doing, map things out. There. Now, an extension to counting to 10 is I could have them create a growing and shrinking pattern, and the growing and shrinking pattern here could be represented so that one side kind of curves out a bit. So if I want to do that, I've got all these different ways to make 10. I could duplicate the last beetle one more time. And then, of course, this last beetle, if I press space, they'll all come back. The last beetle is going to be on top of the final one we just made. So if I do minus 100, will that sort him out? Let's see. Looks like it. Okay, so now I have the 5 sprites. There, they've all drawn lines. Now what I want to have happen is have these lines actually grow and shrink again. So having the students do that, they're creating a growing and shrinking pattern using a coding program they've already used. So the cat would stay the same, but then this value, I want it to go up a little. So this one was 30 and 70. So how could I make this 10 bigger? Now decide which number they're going to change. 40 and 70, and they'll add up 4 plus 7 to equal 11, and this equals 110. So always have them test out their code. There we go. Now, I'm going to go down here to this sprite, which is beetle 4. I'm also going to change this. So 6 plus 4 is 10. 6 plus 5 is 11. So again, we'll test it out and see what happens. Okay. And then finally, the middle beetle, which is beetle 2. When I click the beetle, it shows it right up here. This one has to grow by 1 or 2 more, which in our pixels is 20 more. So 90 could become 110, or 1 plus 11, which would equal 12. And I forgot to press reset. So here we go. So then I've got 10, 11, 12, 11, 10. So there's a lot of ways we could extend the math that we start with. And this is really where it starts to deepen their understanding. What if I run that twice without resetting? What happens then to the pattern? How have the numbers added? How has it changed? About 3 times. And then if we're going to run 3 times, we'd maybe move all the sprites, their X value over a bit. Okay,